Heat review. So heat is 热 in Chinese. 1. Heat definition. So heat is the energy transfer due to temperature difference. Temperature difference. 不同的温度，温度差 in Chinese. And the unit is in joule, just like in the unit for energy. 2, some units for heat. So 1 calorie, C-A-L-O-R-I-E, calorie. It's also called 1 cal. Now 1 cal is equal to 4.186 joule. So joule in Chinese is 焦耳. This is a unit for energy. So energy and heat are very similar, but they are different. So 4.186 kilojoule, right? So kilojoule, I put a K there. So then you also have 1 kilocal. So this K is for kilo. So kilo is 10 to the 3. And then number 3, we're talking about internal energy. Internal energy, 内能 in Chinese. In Chinese, 内 means inside. Internal, so internal means inside, right? 内能. Internal energy, the symbol is U, capital U, and the unit is joule as well. And that's the summation of all the translational kinetic energy. So translational. So this is referring to gas for our discussion, right? Kinetic energy. So that's equal to the total number of molecule, and then times 1/2 the m of all the molecule, and then the average v, translational velocity is average. So these two are equal. So this is the sum of all sum of the translational kinetic energy. So sum of translational kinetic energy for all atoms. Okay. So this is equal to, this U is equal to, if you go and using the equation, which is the Ke bar. So this M is for 1 atom. And this N is total molecule, total number of molecule. So Ke bar, as you recall, is equal to 3/2 K times T from the previous discussion. So this K is Boltzmann constant. So it's a review. So you can put this one into here, right? So then this one here is equal to, this U is equal to N times 3/2. And so this is your Ke bar right there. So KT, yeah. So then we can also rewrite this. So the total number N, sorry, N is equal to number of mole times the Avogadro's number, A, capital A. So this is Avogadro's number. So that's 6.02 times 10 to the 23. So that's number of molecule in 1 mole. So when these two times together, they are equal to the total number. So then this, I'm changing color a little bit. So then this will be equal to 3/2 N, and then N A times K T. So these two together is equal to R. Yeah. So R is the universal gas constant. Yeah. So then we can rewrite this as 3/2 small n R T. And this is universal gas constant. Gas constant. And that's equal to 8.314 joule divided by number of mole. So how many mole do you have? Number of mole, right? And then times degree K. Okay, all right, so that's number 3. It's a little bit longer. And number 4, specific heat. So specific heat is written as small c here, is equal to specific heat. So this is also the speed of light, but it's not speed of light here, right? The small c is also using for speed of light. So specific heat in Chinese is 比热. 比 means compare, and 热 means heat, okay? Specific heat. So this is for water, right? So water is the most common one, which is equal to 4186, and the unit is joule per 1 kilogram, and then per 1 degree C. So to increase 1 degree C, and then for 1 kilogram of water, right, you need 4186 joule, okay? So specific heat is the number of heat, right? The number of heat, amount of heat, okay? Amount of heat needed, right? Needed to increase 1 degree C for 1 kilogram. It may not be water, right? Or any other material, So this is material dependent, right? So this C depends on material. Different material has different specific heat, depends on material. So that's a property for material. So this is a property. 性质, 特性, right? In Chinese, it's 特性. 特 means special. 性 means nature. So property, 特性, right? It's the property of material. So that's that. And number 5 is the formula for the Q, right? So Q is used to represent heat, right? And the unit is joule. And so Q for just increasing the temperature, right? So MC delta T, right? So these are called sensible heat. Meaning the heat that's related to temperature change, okay? So the heat related to delta T. Okay, later we also study the latent heat, which is not related to delta T, but relating to structure change. So in this case, M is the mass, right? So that's in kilogram. And delta T, since it's the delta, we can just using delta degree C, it's fine. So this C, the unit will be joule divided by kg degree C. Okay, because you can see This side is joule, and this is kg, and that's degree C, and this is joule, kg, degree C. So this cancel, 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 cancel. Then only joule left. So that's fine. So it works. Okay, so we're going to talk about the calorimetry. Calorimetry, okay? Well, calorimetry is a 量热法. So number 6, calorimetry. So this is a study, right? So you're ending with a TRY. This is kind of like a method, right? So it's in Chinese, the 量热法. So using this to measure heat, okay? It's a method for measuring heat. So method of heat measurement. Okay, so here, the important thing is the heat loss is equal to heat gain. So what are we talking about? So let's say if we have, say, a cube of, say, copper, and the temperature is, say, 100 degrees C, and the mass is equal to, say, 1 kilogram. And if you put it into a container of water, and let's say the water has a temperature, so temperature of water, T1 is equal to, say, 20 degrees C. And the M of 1 is equal to, say, 1 kilogram also. And now you have the C here for the 1, which is 4186 joule, kg, degree C. And then you have this one here is T2, and this one here is M2. And then you have C2, it's, you know, whatever that you can find in the table. Now, we are going to assume this is an isolated system. So the isolated system here is the copper plus the water. So isolated system means no exchange. Isolated system. So isolated in Chinese is 孤立, okay? 孤立. Isolated system. 孤立系统. No exchange of energy and no exchange of mass. So then that's an isolated system. So in this case, we assume copper in the water is an isolated system. So this is only for the isolated system. So this is talking about heat loss from part of the system. And this is heat gain for the other part of the system. Right? So for example, in this case, the heat loss is the copper, right? And the heat gain here is the water. And it has to be an isolated system. Okay? All right. So now, number 7, changing color. So number 7, we're going to talk about 3 different kinds of systems. So one is open, one is closed, and one is isolated. So one is the energy, and one is the mass exchange. Okay. All right. So for open system, yes, yes. For isolated system, no, no. And for closed system, yes and no. Okay. So this is talking about exchange, right? Exchange of energy and the exchange of mass. And these are referring to system. All right. So that's 7. And now we're going to talk about the latent heat. 8. Latent heat. 潜热. latent heat. So in Chinese, this says qian. Qian means you're hiding, hidden. And heat is 热. Yeah, 热. So this is the heat not related to change of temperature. It's heat, not ed there. Heat related to phase change. Phase change. So phase change here usually involves structure change. So for example, the distance and how they bonded together, right? So if you have ice, then the structure is more, right? So they have a lot of bondage, and so it's a lot more stiff, right? Now when they become ice, now this bondage disappear, okay? So this is the bond. This bond change, right? So then that goes from ice to water. Okay, latent heat. There are two kinds. One is the heat of fusion. Heat of fusion. So this is the heat needed to go from solid to liquid. Okay, so this will be different when you want to go from liquid to solid. So from solid to the liquid, you need to add, right? So this is solid to liquid. This one here is endothermic, right? Endothermic. 吸热的. So in Chinese, endothermic means 吸热的, means you need to add heat into it. 吸 means you suck, okay? You suck the heat. So you need to add, right? You need to add heat, right? For this to happen from solid to liquid. So that's one. And the other one is heat of vaporization. 蒸发, 气化. So vaporization in Chinese is 气化, means 气 means vapor. 化 means change. So changing to vapor. So this is from liquid to vapor, or liquid to gas. Okay, and this is also endothermic. This one here is also endothermic. To go from liquid to gas. So if you go from gas to liquid, right? So gas to liquid, the amount will be the same, but the sign will be opposite. So gas to liquid, this one here is exothermic. So 放热的. Exothermic in Chinese means 放热的. 放 means release. So release heat. And also you want to go from liquid to solid, it's also exothermic. So they will release heat, okay? So both of them are as exothermic. All right, so they are different, right? This heat are different and they don't change temperature. So no change of temperature. Okay, so that's latent heat. And now we're going to talk about a diagram to go from ice to vapor, okay? Right. For water, for example. You can do it for other material, but we're just going to do it a diagram for from ice to vapor. Okay. So the y-axis is the temperature, so degrees C, temperature. And the x-axis is the heat, so Q. So it will be in kilocal, or it's in kilojoule, or in joule. So in this case, we're going to do kilocal. Okay. So we're going to start with negative 40 degrees C. So that's ice. So this is ice at negative 40 degrees C. And the vapor is going to go up to, say, 1000 degrees C. Okay, so what's the process of that? So we're going to need this ice to increasing temperature. So this is the heat that's needed to increasing temperature. So this is using, this one here is using mc C delta T. It's like a, mc delta T. And this C is for ice. This is C for ice. And then we're going to have heat of fusion. So this one here is going to be 0 degrees C right there, 0 degrees C. So this is going to be heat of fusion. And the formula is going to be heat is equal to L times, the L is the latent heat, right? So this is LF. So this is latent heat of fusion. Okay, so times the mass of the ice. Okay. And now this is going to continue, and then let's say it's going to go from the 0 degrees C and then increasing temperature to say 100 degrees C here. So that will be 100 degrees C, and now it's ready to boil. So this is using, again, this is using mc delta T. But this C here is using water specific heat. And that's specific heat for ice, right? So now you reach the 100 degrees C. Now you'll be another latent heat, and that will be latent heat of vaporization. So it's LV, latent heat of vaporization, right? I'm going to write it again. And then later, so this is going to continue. And this one here is going to increase the temperature again. And this one here will be the mc delta T again. And this C are different, right? This C is C1, and this C is C2, and this C is C3. They are different. So this C3 is for the, so what was this? This is vapor, right? This is already vapor. So this is for the water vapor, right? So for vapor, water vapor. Okay, so that's how you calculate when you go from negative 40 degrees C to 1000 degrees C vapor. So you would add all the Q together. Q is going to be equal to mc1 and then 0 minus negative 40. So 0 plus 40 and then plus LF and then times your mass. Let's say it's 1 kilogram. You can put a 1 there. And then plus this one here is 1 kilogram. So M and C2, just you're gonna go check the table for water, and this go from 100 minus 0, because this is 100, that's 0, and then plus the latent heat again, the LV, gotta check the table, and then times the mass again, at 1 kilogram, and then you plus MC3 delta T. So let's say go to 1000. So then you have 1000 minus 100. So that's how you calculate this. And this will be in terms of joule. So that's number 9. And then we talk about heat transfer. And then we'll be done. Number 10. So heat transfer. The first one is conduction. So conduction, the formula is, so conduction is a heat transfer. So this in Chinese is 传导. 传导. So 传 means propagate. 导 means like a conduct. So heat transfer through collision. of neighboring particle. So they are close. They are not very small distance. Neighboring particle, neighboring atoms. So small distance. So the characteristic is small distance. And then the other characteristic is collision. So 撞击. So collision in Chinese is 撞击. Okay, 撞击. So this is the formula is Q and the heat, right? But Q we have a divide by temperature by time. Okay, this is time. So this will be in terms of watts. So watts is equal to joule per second, right? So that's equal to K, which is the thermal conductivity. So thermal conductivity is a property of a material, right? Thermal conductivity. 热传导系数 thermal conductivity. So 传导, right? And 热 just means heat, right? 热传导系数. And 系数 just means the constant of proportionality, right? Right. So 系数 is constant of proportionality. Right? 热传导系数 thermal conductivity. So this is a property of material. 特性 property is 特性 again. Property of material. So K times area. The larger the area, the faster you will conduct. So that kind of makes sense. And then the larger the temperatures, the delta T, so it would be T, say 1 minus T2. You can write T2 minus T1. It's your choice. Just keep in mind, if you want positive, this one here, T2 need to be larger. And then divide by the distance L. So let's say if you have material, and this side here, you have a temperature. Let's say you have a temperature of, say, T1. And T1 is larger than T2. And this distance here is L. And this cross-section here is A, cross-section. So A is cross-section, which is a meter square, right? So meter square and cross-section, 截面积, so cross-section area. So in Chinese, cross-section is 截面积. Mianji just means area. 截 means cross, like you cut it. Because cross-section, and then T1 minus T2, so T1 larger than T2, so this side is T2. So you know the conduction is going to go this way, right? The Q is going to go that way. Because high temperature to low temperature always. And so it's the temperature difference. So this is T1 minus T2, right? This is temperature difference. It's also called delta T, right? So the larger the temperature difference, the larger that you would have, the transfer per second, right? So that means the watts. In the larger the thermal conductivity, let's say the largest one that for K, the largest one is probably like something like silver, right? Silver, this is large, okay? Okay, for silver, this is large. And for wood, it's small, for example. For wood, it's smaller. Okay, this is small. So if you have large K, the large K, so I'm going to change in color here because we're getting kind of crowded. So it's called thermal conductor. Thermal conductor. So in Chinese, it's called 热导体. 热 just, thermal here. 导体 means conductor. 导. So same word here. 热导体. Right? So thermal conductor means K is large. Now, for example, like silver. And then thermal insulator, also like wood, right? So this is like wood, right? So this is 绝缘, 热绝缘体, 绝缘. 绝 means stop, and 缘 means Means kind of like a, you know, like a luck actually. Yuan is kind of like a luck, like, but it's like you stop that luck, meaning that you don't conduct. Okay, so 热的绝缘体. So that's the formula for heat conduction, right? And the unit for K is going to be, you can see this is watts, right? So it has to be watts, right? So it has to be joule per second is watts. So it has to be like that, okay? And the areas on top, so you got to have meter square at the bottom, right? But then you have the L there, so that cancel one meter. So that's going to be like that. And then you have a degree C there. So that's the unit for the thermal conductivity. So when you cancel all the M and A, the A and L, then the M is gone. When you cancel out the degree C, that's gone. So it becomes joule per second, and this is joule per second on the left-hand side. Okay, so that's the conductivity. And then number 11 is going to be convection. So convection, it's a little different. Convection. So the second method of heat transfer. So it's called, in Chinese, it's called 对流. 对 means opposite. 流 means flow. So this one here is the heat transfer due to large motion of bulk, means a lot, okay? Bulk means a lot. 很多, right? Bulk means 很多 in Chinese. Large motion of bulk material or fluids, right? Okay, so the example is like when you have a pot of water and we have fire, and then this original is cold water, say 15 degrees C, and it's going to increasing temperature. So then this side is going to be hotter, right? Because it's closer to the fire, and this side is going to be colder. So then because of this hot and cold, so the density is different. So you have a delta in terms of Zo. Zo is density, right? Okay. So Zo is small for hot water, and Zo is large for cold water, right? So then this is large, so it's going to go this way, and hot is going to go that way. So this motion of water particle, and it's a lot of water particle, right? It's not like the conduction. Conduction is only, like, let's say you have this conductor, and it's between this atom and the atom that they are colliding each other, right? So this is a conduction. 热传导, right? So they're just neighboring. This is neighbor, small distance, right? Small distance. Collision, right? Small distance collision. But this is a large motion flow, right? Large flow of bulk fluid, bulk material. So that's the difference between heat transfer and convection, right? So number 12, it's going to be radiation. And that's it for this topic. So radiation, the formula is Q divided by T. So same thing, this is joule per second. And that's equal to epsilon. This is emissivity. So emissivity is a property again of material. 特性, property is 特性, remember? Property of material. And this is between emissivities is larger than 0 and less than 1. So if you have, let me change in color. If you have black body, black material, right? So like a charcoal. Like charcoal. Okay. This one here is emissivity is equal to 1. So if you are good emitter, then you're also a good absorber. Well, obviously he's black, so he absorbs everything, right? But when you absorb everything, you're also very good at emitting energy out. So you have this epsilon equal to 1. And epsilon equal to 0, it's like the snow, right? So it's like a reflective material, reflective. So you only reflect, you don't absorb, right? So only reflect. Reflect in Chinese is 反射, means 反 means opposite, right? 射 means shooting. So it come and you give it a shoot, a shooting to the opposite direction. So 反射. So that's epsilon equal to 0. So this emissivity, and then times a constant. This is sigma. Sigma constant here is Stefan Boltzmann. So Boltzmann we are familiar because we studied that already. So Stefan Boltzmann. So there's some kind of collaboration between the two. Boltzmann constant. Or their work kind of overlap. So this is the Stefan Boltzmann constant. And that's equal to 5.67 times 10 to the negative 8. And the unit is going to be watts, because this side is watt. That's equal to watts, right? Watts. So the unit is going to be watts. And then you have this one here is also times area, and then times T to the power of 4, right? So then this has to be the watts, and then divide by meter square, because area is meter square. So you have to cancel that one out, and then times this K. So this is not delta T, but T. So this is absolute temperature. So that's in degree Kelvin. That's in degree Kelvin. So times degree Kelvin. So that will be the unit for the sigma. All right. So that's all we have for this chapter. And thank you for watching. And keep watching, keep learning more exciting physics. And if you like it, don't forget to subscribe. Bye now. 多订阅，拜拜。